Thanks for inviting me to this school, and I'm happy to explain a bit the work of the International Earth Rotation and Reference System Service, the IERS, and show you a bit about the organization of the IERS and the most important products that you might using as a user. So a bit of history. The IRS was created in 1987 under the name International Earth Rotation Service. And when it was created, it had two parents, let's say. The first one is the International Astronomical Union, the IAU. And the second one is the International Union of Geodesy and Geophysics, where the IAG, the International Association of Geodesy, belongs to. When the IRS began its operation on January 1st in 1988, it was not something completely new, so there were two predecessors taking care about Earth rotation and time, and the IRS replaced these two institutions and these two services. The first one was the International Polar Motion Service, and the second one was the Earth Rotation section of the Bureau International de l'Eure. After roughly 20 years of work of the IRS, one recognized that it would make sense to change the name a bit and add reference systems to the name. So not only Earth rotation, but also reference systems. So it was decided in 2003 that the new name of the service is International Earth Rotation and Reference System Service. The acronym IERS remained the same. And this change in the name should reflect better the responsibilities of the IERS, because for providing really good Earth orientation, you heavily rely on accurate and well-defined reference systems. So both aspects are important. And the IRS as a service functions as one of the IAG scientific services. So what are the goals of the IRS? The IRS provides several products to the international scientific communities. The first product deals with the celestial reference, and the IRS provides the International Celestial Reference System and its realization, the International Celestial Reference Frame. The second product is the terrestrial reference. Here, the same, similar to the celestial reference, the IRS provides the International Terrestrial Reference System, ITRS, and its realization, the International Terrestrial Reference Frame, the ITRF. The third product are the Earth orientation parameters, the EOPs, that are relevant for transforming between celestial and terrestrial reference frames. Additionally, we need conventions for generating these products, reference frames, and EOPs, but also for using them. That means the IRS defines common standards, common models, constants, mathematical descriptions, etc. And finally, an important product are geophysical data that are relevant to study and understand the variations in the reference frames as well as in the Earth orientation. And it's important to note that all products that the IRS is providing are open access. That means free of charge, available. And due to the nature of all these data and products, there are many operational users, especially also in the navigation field. To do this job and provide the products and generate them, the organization of the IRS looks as follows. We have a management part, of course, of a service. So we have the IRS Directing Board, where all elements of the IRS are represented with voting members. For the operational management, we have the Central Bureau. I will come to this later. And for the scientific management, we have a so-called analysis coordinator. And then we have several elements dealing with the product generation itself. So in the first column, you see all the product centers dealing with Earth orientation, with the conventions, with the two reference systems and frames, Celeste and Terrestrial, as well as the global geophysical fluids, which are separated in the three components: ocean, hydrology, and atmosphere, and also a special bureau for combination of these three elements of the global geophysical fluids. For generating one of the major products, the ITRF, we have 3 ITRS combination centers. I come to this in a minute. And as an input, we are using the space geodetic techniques. And you're aware that all the 4 space geodetic techniques are as well organized within an IAG service, namely DORIS, we just heard, is organized in the IDS, similar for the GNSS community, is organized in the IGS. The SLR, LLR community is organized in the ILRS, and the VLBI community in the IVS. So all these 4 services are included in the IRS as so-called technique centers, because their observations, of course, are important to generate all the products. And for specific investigation, developments, and studies, we have within the IRS several working groups which have usually a limited time span, depending which topics are important to study at the moment. So we have 3 major products: the celestial reference, the terrestrial reference, and the Earth orientation. And all these 3 products are strongly connected because the Earth orientation parameters represent the transformation between celestial and terrestrial reference frame. And as a consequence, this means that the IRS is striving for high consistency, or the best possible consistency, between all these 3 products. One must admit that in an ideal case, this is not yet realized because it's not that easy as you can imagine, but we are working on this continuously, and we also have a dedicated working group that really looks at the consistency between CRF, TRF, and UOPs. So one word about the definitions between systems and frames to make this clear why the IRS always is speaking about both. The reference system is, so to say, the theory. You define mathematical models, you define conventions, standards, all the theory, let's say. But at the end, you want to have a product that is really materialized. So in terms of a terrestrial reference system, you want to have a frame, and this is the realization of the system, and contains, you know this from the TRF, positions and temporal variations of your geodetic stations. And to do this realization from a system to a frame, you need the geodetic observations from the 4 space geodetic techniques: GNSS, VLBI, SLR, and DORIS. You know, we have global networks of all 4 techniques, and based on these observations, you generate a reference frame. This means you can have, depending on which kind of observations, subset of observations you're using, you can generate different frames which belong to the same system, but not the other way around. So have a closer look on the three major products of the IRS, first starting with the terrestrial reference frame, the ITRF. This is a really multi-technique product, so that means all the four space geodetic techniques, GNSS, VLBI, SLR, and DORIS, are included with each of the services. They are providing the input in form of SINEX files. And then we have three ITRS combination centers that are combining this input by the four techniques. And the three combination centers apply different combination methods so that at the end we have slightly different products. But in principle, the content of the product are of all these space geodetic observing sites, the three-dimensional positions and linear velocities. And additionally, we have since quite some time nonlinear modeling. This is different how the three combination centers handle the nonlinear part. It could be post-seismic deformation model with logarithmic and exponential functions. It could be annual, semi-annual signals, but also non-tidal loading models based on geophysical fluid data are used. The update cycles of the ITRF changed just recently. So until ITRF 2014, we had, roughly speaking, every few years, 5 years, a full update of a fully new processed TRF. Since ITRF 2020, the philosophy changed a bit. So we have a full series ITRF or full update ITRF 2020, and then yearly extensions of an ITRF 2020. And I will show you this in a bit more detail. What does it mean? So we have with ITRF 2020 as the latest long-term realization of the ITRS 1 product that was published in April 2022 by the Product Center at IGN France. And this long-term realization really comprises all observations that had been taken since the very beginning in 1979 until every data available in the year 2020, which is the label of the ITRF 2020. The official ITRF 2020, as I said, was provided by IGN France. But there are additional solutions, DTRF provided by DGFI and a JTRF 2020 provided by NASA JPL. And now we implement within the IRS yearly updates of this long-term realization ITRF 2020, which means we do not take the full data set of 40 years. We just add the most recent years. So ITRF 2020 ended at 31st December 2020. And then for the first update or extension, we used only the data starting 1st of January 2021 until December 2023. This update or extension is already finished, was published last year. And a second update, just taking the data of the year 2024, is in preparation at the moment, and I guess it will be published in summertime. And maybe Zuhair later on will tell you a bit more about the timeline. Why are we doing this? The main goal is reduce the workload. Instead of taking 40 plus years of data, just take the most recent years. And there it is important because we have a lot of new sites, especially with the new VGOS technology. They were coming up in the recent years, and there it is important to get regular updates and improvements of the coordinates and the velocities. Coming to the second product, it's the Celestial reference, the International Celestial Reference Frame ICRF. This is at the moment a VLBI only product, so it's not combined with other techniques, and it's even not fully consistently combined within VLBI. So not several analysis centers are really consistently combined. but just taken one or two solutions as the final ones and do comparisons. The content of the product are the directions or positions of the quasars that are observed by geodetic VLBI. You see here a picture of the sources, the quasars that are included for the X-band, the classical VLBI frequency. That's more than 4,000 sources that are included. Additionally, several hundred of sources are included for the K and Ka band. And currently, as I mentioned, the VGOS sites, we also have extensions necessary for the celestial reference frame for the VGOS frequencies, and this is in preparation within the IVS. Here, the update cycles of the ICRF are a bit longer than for the ITRF typically, so many years, 5 to 10 years, not that regular, until a new catalog is published. The current version is named ICRF 3. This was adopted by the IAU General Assembly 2018 and then became active as the official reference frame on January 1st in 2019. And here, especially the cooperation between the ICRS and the IAU, the International Astronomical Union, becomes obvious because the ICRF 3 was prepared within an IAU working group on ICRF 3. Finally, we have the Earth orientation parameters, of course, as the IRS. There we have two product centers. The first one is called Earth Orientation Center, located at the Observatoire de Paris. And the second one is called Rapid Service Prediction Center, located at the US Naval Observatory. The first one, the Earth Orientation Center, is responsible for the long-term monitoring of Earth orientation. And one of the most prominent series that you might use in your work is the final IRS EOP series, thought to be the best one what you can provide, and it's named CO4. It's a final series. That means you take a bit of time to generate this. So that means the latency of the product is roughly 30 days. So the series that is published today has the latest epoch 30 days ago. Additionally, the Earth Orientation Center publishes time disseminations and leap seconds announcements. And you see on the right, the time series of UT1 minus UTC of the CO4 series, where all the leap seconds are visible as these jumps in the time series. As I said, CO4 has a latency of 30 days, so there are many users around that need more frequently and with lower latency Earth orientation information. That's why the second product center generates so-called rapid IRS EOP series, and you might know this with the names Bulletin A or Finals Daily. And these series have latencies of 1 week or even below 1 day with an update. Additionally, predictions are provided by USNO for the Earth orientation parameters. All EOP series are aligned to the most recent ITRF. As I mentioned earlier, the agreement and consistency is very important between reference frames and EOPs. And that's why you see on the top of the plot the name EOP 20 CO4. That means this is the CO4 series aligned to the ITRF 2020. And all EOP series are multi-technique combined products. So finally, some words about the IRS Central Bureau, which is operated here by BKG in Frankfurt in Germany, where I'm the director of. We are responsible for the general management of the IRS and the executive arm of the IRS Directing Board. What is more interesting and more important maybe for you as a user of any products and data sets of the ICRS, we maintain the central website of the ICRS. You can access it under this address listed here, and you see a screenshot of the starting page. There you find a lot of information, general information. Then, of course, you can access all data and products, publications of the ICRS, because we also maintain a central data and information system for all products of the ICRS. To document the most important products, we generate publications, so-called technical notes. The most recent technical notes are on the analysis and results of the ITRF 2020. In preparation related to TRF 2020 is a technical note with describing and evaluating the various realizations for TRF 2020. And a third one, just recently published technical note, is on the second Earth orientation parameter prediction comparison campaign. Finally, for documenting the work within the ICRS or for all components, we are publishing so-called annual reports. And just for your information, the annual report 2019 was the first one, which was also published with DOIs for the entire series, for the volume itself, and for the individual reports contained in the annual report, so that you can get credit for every individual institution and contribution to the ICRS. And with this, I want to thank you for your attention and I'm open for questions.